Welcome back, everyone. We're going to be solving LeetCode 1351, count negative numbers in a sorted matrix. So we're given an m by n matrix called grid, which is sorted in non-increasing order, both row-wise and column-wise. And we need to return the number of negative numbers found within this grid. And we do have a follow-up question, but they ask us to solve it in O of n plus m time, so we'll try to do that right off the bat. So if we take a look at example 1, we have a grid with 4 columns and 4 negatives here, 2 more to make 6, 7, and 8, right? So that makes our output 8. So we know we're going to have a variable to track the counts, so we'll just say count, and we will start it off at 0. Now, in order to get this, right, this O of n plus m solution, we are going to have to do, actually we could do something better. We could do binary search, so we'll do that. But you could brute force this, right? You could loop through every row in this grid, and then just whenever you run into a negative number, increment the count variable, but that's going to be an O of n squared solution. So let's implement binary search. We'll say for row in grid. What do we want to do? We want to get a left and right pointer. We will set left equal to 0, and right will be initially set to the length of our row minus 1. Now we need to find the midpoint. So we'll say while left is less than or equal to our right pointer, we want to say our middle point is going to be, and we want to avoid integer overflow. Now it's something you don't have to worry about in Python, but if you're working in Java or C++, right, you're going to have to know how to do this, so we'll just take care of it in Python. We'll say low plus, and we'll get divided by 2, and this will be high, so high minus low. Update my variables here. Okay, so that is our middle point. Now what do we want to do? We want to say if the number at the middle point in our row, right, if it's less than 0, what can we do? It means we found a negative number, and we need to essentially check the other portion of our array. So we want to move our right pointer to the middle point minus 1, and then just recalculate our middle, and so on and so forth. So we'll say right will now equal our midpoint minus 1. Otherwise, if we run into a case where the middle point, the element at the middle point is greater than 0, right, we can just set our left pointer equal to the middle point plus 1, right? We want to move it up. And now, once we exit this loop, we want to, potentially increment our counts. So we'll say counts is now going to be incremented by the length of our row minus whatever our left pointer is currently at. And then at the end, we can just return count. So what does this give us? So we pass both test cases, and it does run. So we'll come back here, get rid of some spaces, and the time complexity is going to be, right, we're looping through every row in grid, so that's already O of n, but binary search is log n, so that is going to make our time complexity O of n log n, and our space complexity is going to be constant, right? We're not working with any other data structures, so we'll be O of 1 for space. And let's run through an example before we end the video here. So let's get these up. Okay, so let's loop through the first row, right? 4, 3, 2, and negative 1. We got our left pointer at 4, right pointer at negative 1, right? We come in here, we find the middle point. The middle point is going to be 2. It is not less than 0, so now we will take our left pointer, right? we'll execute this block right here. Our left pointer will now be equal to -1. And then we will update our count, right? We're still in this first array, this first row. It'll be the length of our row, which is 4, minus whatever position our left pointer is at, which is the last position in our row, which happens to be 3. 4 minus 3 is 1. There is indeed one negative in this row. Move on to the next one. We do the same thing. We get one more negative added to our count, so now we have 2. Come to the next one. Left is at 1, right is at -2, midpoint is a negative in this case, so we will say right is now going to be moved to here, and then we execute the next iteration. Left will now be equal to midpoint plus equals 1, so now our left pointer will be here. We can calculate the row minus the left point, right? We'll get another 2 added, and then so on and so forth, and we will get an output of 8. All right, that'll do it for LeetCode 1351.